Hey guys, this is a clip on unit rate as slope. How do we calculate unit rate as slope? Based on any given table, how do we figure that out? And also, how do we solve for anything that might be missing in our table, such as this right here, this x, and how do we graph this? And then the second part of this is going to be, how do we compare different rates, unit rates? How do we gather the unit rate? How do we calculate it? And how do we compare it? A little bit because it's kind of shiny here, a little reflective. So we're going to talk about this in a second. So let's start with this one, unit rate as slope. Julie drove to Tampa on the back roads. The table below shows her time and distance. Calculate her unit rate and then graph the results. If Julie decides to travel the rest of the coast of Florida using the back roads, how long will her trip of 750 miles take? So we want to start at the beginning. And we want to find out what our change in y is over change in x. Now typically on a graph, our y-axis is going to be something that increases, like distance, money, something that we can gather, right? Something that can increase numerically. So in this situation, we're going to put distance here. So distance is going to increase. We can't decrease on distance. We can't go down on distance. Distance is always increasing. Time, very similar. We can't go back in time, but time is very linear. So time typically follows follows a linear path, right? It's going to go in this direction. So that's typically our x. It's not always the case. Sometimes you can find time on this axis and something else on this axis. It's possible, but a lot of times you'll notice that time goes down here. So it could be seconds, it could be minutes, hours, days, months, years. A lot of that's going to be down here. Okay. So let's take a look at this right here. So distance is change in y. So if I go from here, let's say I start here, let's say I start here and I go up to here. So that's going to be a change from here to here on the y-axis. Okay, so that's change in y. So this is going to be change in y over change in x. And basically that's what slope is all about. Slope, what we refer to as m, slope is change in y over, like a fraction or a ratio in this situation, a change in x. You can basically divide the y by the x. Okay, this typically works well in proportional relationships. So if we put 15 where y is, and we put 30 down below, we can get some kind of rate. Now if we put this in Low's terms, we get 1/2. So basically what it means is it's 1 mile in 2 minutes. Now this is a rate, but it's not considered unit rate yet. Most people are not going to say, I'm going to go 2 minutes in a mile. That doesn't make a lot of sense. You're going to say, I'm going to go 1 mile in 2 minutes. So 2 minutes is still not unit rate. Unit rate is where the second quantity, this is the second quantity, where the second quantity is 1. You want it to be 1. You want it to be 1 minute. So in order for us to go from 2 minutes to 1 minute, I have to divide by 2. Right? So if I divide this by 2 to get to 1, that's fine. We can do that. But whatever we do over here, down below, we have to also do up here. So we're going to divide 1 by 2. We could either get 1/2 mile, right? Or we can write this as 0.5 miles. Okay, and it's really up to the person that's doing the math, they could do either one. So they could just say 1/2 to 1/2 mile in a minute, or 0.5 miles in a minute. So it's kind of up to you how you want to write that. Now down here, if we fill this out, if we plug in our graph, well, first we got to create it, right? So you can see the blocks that I have. So we want to look at our numbers and kind of figure out kind of where should we start. We start at 0, and as you can tell, they increase by 15 each time, right? So if you want, we could do it by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, right? We could do it that way. We could do it by 15s. So if you don't want it to be that high, we can say maybe every 2 blocks is 15. So this could be 15, this could be 30, this could be 45, this could be 60, this could be 75, and of course 750 is not even gonna fit on this. Let me see if I can do the focus on this a little bit better. For some reason the focus doesn't seem as great. Okay, and then for time, I've got 30 minutes, and I've got 150 minutes. So obviously we could probably just do every 2 as well, if that works for you. We could do every single one, but it'd be kind of tight. Everything would kind of fit right here, between here. I would probably do every 2 or every 3, but you can see it's consistently 30, 60, 90. So so we're adding 30 minutes each interval. So we can say 30 here, 60, 90, 120, and then 150. And then 60 right here. Okay. And then what we're going to do is graph it. Let's see if I can move this back just a little bit. All right. And I apologize for the shininess and just the reflection here off this paper. All right, so let's do it. So 15 and 30. So 15, the distance of 15, the time of 30. So it's going to go right here. Then we got 30, 60, 45, 90, 60, 120, and 75, 150. And then you take a ruler, connect the dots, and obviously it's going to continue in that direction. Now again, 750 is going to be too far out. We're not going to be able to do that here. So what you're going to have to do is you're going to have to take this ordered pair and you have to plug it into your equation. So the question is, what is the equation? Remember, the equation typically on a proportional equation, which basically starts at the origin, starts at 0, it's y equals kx, which basically means k times x. If we've got y is 750. Okay, we don't have the x yet, but we do know what k is. K is our rate. This is our rate, our unit rate. It's 0.5 miles per minute. Okay, so 0.5 is going to be right here. It's a little wonky there. I don't really like that. Sorry. I'm a little bit more of a perfectionist, I guessed. So we're going to say, we're going to make this just a little bit smaller. Okay, so 0.5 times x. Okay. Now, you could have put 0.5 over 1, but really anything over 1 is just that number, right? So that's why it's just 0.5. Because normally the equation, if we didn't have 750, the equation would just be y equals 0.5x. That would be the equation. But since we know what y is, we just plug it in and then just leave x alone and solve for that. So this is basically just a one-step equation. We can just simply solve for x, and then we're going to divide both sides by 0.5, because that's the opposite of multiplying by 0.5. So we divide both sides by 0.5. And then this is going to become x, and this will become 1,500. And that's basically going to be your answer right here. So in order to go 750 miles, it's going to take her 1,500 minutes. And for time, if you want to know what that is in hours, you just divide this by 60, and you'll get your answer. Which would be what? Let's see. This is in minutes, right? So if we want to change minutes to hours, divide that by 60. Let's see. Let's cancel that out. We can actually divide this by 6, can't we? Yeah, 6 goes in one fit pretty evenly. Goes in twice, 5 times. So, okay. So 25 hours. That's a long road trip. Okay, I don't know who wants to do that, but never know. Anyway, so that's basically it. So it's going to take her 25 hours to go 750 miles on the back roads. I think I'm going to stick with I-4, unfortunately. Anyways, so this is it on unit rate and slope for part 1. Part 2, I'm making another video just so this video is not too long, okay? It's already 11 minutes, so I'm going to go ahead and close this now and do unit rate as slope part 2 here in a minute. God bless.